Hi everyone, we're Team 41. In Phase 1, we turned a noisy newsroom dataset into a clean version-controlled pipeline and a first set of share prediction models. Over the next 10 minutes, we'll show you the highlights and the handoff to Phase 2. Quick roll call. Stephen is our data scientist, Felipe the ML engineer, Angel the data engineer, and I cover software and MLOps. Each of us will take 2 to 3 slides. Let's dive in.
Here's the path. 1. Problem framing. 2. Canvas analysis. 3. Data prep. 4. Exploratory analysis. 5. Data versioning with DVC. 6. Model construction. 7. Results. 8. Role interaction. 9. What's next? And 10. Conclusions. First, the problem. We use the online news popularity data. 39K mashable articles, 61 attributes, target is the share count. Business objective, estimate popularity pre-publication, so editors steer promo budget to likely winners. For realism, our instructors injected noise. Phase 1 tests whether we can clean, validate, and statistically reconstruct that data. The canvas formalizes the problem. Prediction task equals regression on shares or a binary viral flag in phase 2. Impact statement equals stop promoting low impact pieces, boost surprise hits. Main risks equals wasted ad spend and hidden bias by section or weekday. These assumptions drive the metrics, the data contracts, and the guardrails you'll see in the pipeline.
We started with severe corruption, wrong types, mixed strings, impossible probabilities, even a fake column. Our notebook 1 coerces every numeric column, 2 applies 20 domain rules, probabilities in open bracket 0, 1 close bracket, polarities in open bracket, -1, 1 close bracket, weekday exclusivity, LDA rows that sum to 1, 3, clips outliers with mu plus or minus 3 sigma from the original reference, 4, verifies integrity. The final correlation matrix gap is only 0.0297, so structure is preserved. Output file df underscore final underscore validated.csv is the single source of truth for modeling. On that clean set, we ran an intermediate EDA, distributions, correlations, and outlier heat maps, key actions, scaled numeric features, one hot encoded 13 binary flags, dropped 12 redundant columns that were 95% correlated with others. Result, a balanced matrix of 46 predictors ready for training.
Everything you just heard is reproducible in DVC. The pipeline has 3 stages: 1 clean arrow, 2 profile arrow, 3 train. Each stage logs artifacts and metrics. Every push to Git generates a runner on GitHub Actions that checks the hash and stores the clean.csv plus the visual report. That gives us traceability and an audit trail. Because DVC guarantees the exact dataset, we could benchmark models reliably. Linear regression and k-nearest neighbors after grid search deliver CV RMSE around 4 k-shares, MAE about 2,350. R-squared is low, which is common with heavy-tailed targets, but variance is under control. These numbers set the baseline for future iterations.
We split train, val, test 60, 20, 20. 6 model families were tuned: linear, ridge, KNN, decision tree, random forest, XGBoost. Evaluation on the held out set uses RMSE, MAE, and R squared. XGBOOST and random forest scored best but were overfitting. Linear kept the lowest variance. We kept the linear model as the production candidate. RMSE equals 4018. MAE equals 1851. This table shows the gap. XGBoost barely beats linear on the test slice but explodes on unseen folds, variance of plus or minus 1,800 shares. KNN with K equals 15 is a stable runner-up, simpler models underfit. Key takeaway: linear is good enough for a pilot. We'll revisit ensembles once we have drift monitoring in place.
Data engineer pulls raw dump nightly, runs the DVC clean stage. Stephen, data scientist explores new features and registers experiments in ML flow. Felipe, ML engineer retrains and promotes a candidate. CI/CD deploys a new Docker image. Anna, software engineer wires the Fast API endpoint back into the CMS and monitors service health.
Phase 2 is live data tracking and feature optimization. Phase 3 is containerized deployment. Tasks already booked. integrate Evidently AI for drift detection, spin up a blue-green Fargate service, and connect an editor dashboard so predictions appear inside the CMS.
To wrap up, the dataset is now statistically indistinguishable from the reference. Every artifact is versioned with DVC, baseline models reach the 4K RMSE bar, the repo is production ready for phase 2. Immediate next steps, log experiments in MLflow, hypertune XGBoost, and add SHAP for explainability.
All notebooks, DVC files, and the FastAPI stub are public at the link on screen. Feel free to clone, run DVC repro, and you'll get the same numbers we just showed.
Sources include the original online news popularity paper, the machine learning Canvas license, and docs for DVC, MLflow, and Evidently. All citations are in the repos README